Good afternoon, everyone. Thank you for joining us today at the University of Toronto's Routledge School of Management. My name is Nisarg Shah. I'm an associate professor here in the U of T's Department of Computer Science, and I'm a research lead at the Schwartz Reisman Institute for Technology and Society. And I'm very excited to introduce today's special in-person edition of the SRI seminar series with our guest speaker, Rohan Alexander. Before we begin today's session, let me take a moment to acknowledge the land on which the University of Toronto operates. For thousands of years, this land has been the traditional land of the Huron-Wendat, the Seneca, and the Mississaugas of the Credit. Today, this is still the meeting place and this meeting place is still home to many Indigenous people from across the Turtle Island, and we are very grateful to have the opportunity to work on this land. Okay, a few important logistics for today's seminar. This session is being recorded. The presentation will run for about 45 to 50 minutes, and this will be followed by a Q&A session. Now, for those of us here in the room with us, we ask that you please raise your hand during the Q&A session if you want to ask a question, and speak clearly so that your question is captured by the microphones that are embedded in the ceiling for the online participants, and they are also recorded. So no microphone is needed for this session today because this room is configured to pick up audio from throughout the entire space. That's a good thing because we don't have to run around with the microphone, but it also means that if you are having any side conversation with the person next to you, that will also be picked up by the microphones. Everybody on Zoom will also hear that, and it will be recorded for eternity. Okay, so please do not have any side conversations until the session is completely over, and that means until the end of the Q&A session. Okay. We will have time after the session ends for a little bit of mingling and conversations, and also for you to meet the speaker and spend some time with the speaker. All right, now for people who are joining us online, we welcome you to use the raise hand function in the Zoom if you want to ask a question during the Q&A. If you don't want to ask the question by unmuting yourself, then you can also write the question in chat, and then we'll be able to pass your question on to Rohan. All right, so without further ado, let me introduce today's speaker, Rohan Alexander. Rohan is an assistant professor at the University of Toronto, jointly appointed by the Faculty of Information and the Department of Statistical Sciences. He is an assistant director of CanC Ontario, a senior fellow at Massey College, a faculty affiliate of the SRI, and a co-lead of the Data Science Institute's thematic program in reproducibility. Rohan's research investigates how to develop workflows that improve the trustworthiness of data science, and this is partly the subject of his talk today as well. He's particularly interested in the role of testing in data science. Rohan's recently published book, Telling Stories with Data, which is fantastic, by the way. So if you haven't gotten your hands on it yet, please do so. It argues that a trustworthiness revolution is needed in data science and proposes a view for what this could look like. His teaching helps students from a wide range of backgrounds learn how to use data to tell convincing stories. Rohan is an associate editor of the Journal of Statistics and Data Science Education and a co-organizer of the Toronto Data Workshop and the Toronto Workshop on Reproducibility. So, Rohan, the floor is all yours.
Thank you very much. So thank you very much. I haven't been this nervous before a talk since my job talk, so I'm not sure what it is about this audience, but thank you very much for having me. Today I'd like to talk about improving the reproducibility of quantitative social science. My background, I have a PhD in Australian economic history. And so, as you'll see in the rest of the talk, basically, in my opinion, the quantitative social scientists have very much become very similar, and so that's why the talk is sort of about all of quantitative social scientists. And I see we've got some political scientists in the room and some sociologists, and so hopefully widely applicable. In terms of what I'm going to talk about, I'm just going to start with a background which will sort of put us all onto the same page in terms of where we stand in terms of the quantitative social sciences, because I'm aware that, obviously this is more of an AI sort of focused group, AI technology focused group. So just ensuring that we all agree on where we are and what some of the current challenges are. In the second point, in the second part of the talk, I'll then focus on workflows, because I think that really what we need right now is an improvement in how we go about doing our work as quantitative social scientists. And then in the third part, I will talk about how we can adopt AI to implement these improved workflows and ensure that the changes that I think that we need to make to the quantitative social sciences can be made sometime within hopefully my lifetime rather than anything else. The key takeaways from the talk. So if you pay attention to nothing else, I'll just pay attention to this slide. The key takeaways are that economics, political science, sociology, we are now just as code dependent as any of the computer sciences, software engineering, any of those fields. Basically, what we do is we write code to analyze data, and it happens to be about society and humans, but it is all code-based. There have been considerable improvements, especially over the past 20 years, in terms of the reproducibility of what we are doing. However, it is happening very, very slowly. And this is largely due to sort of natural and understandable cultural reasons, but I think that we can use an AI-informed approach, in particular large language models, to try and speed that up so that humans, quantitative social scientists, don't have to really change the way that they are doing things. We can just take advantage of technology to do that for us. Just by some caveats, as I mentioned, my PhD, and as you can probably tell from my accent, my PhD is in Australian economic history. My position at the university uniquely allows me to be exposed to a large number of disciplines across the university. It's a great, and I'm very fortunate to be in that position, but I'm not an economist, I'm not a political scientist, I'm certainly not a statistician. So, these are just my opinions, and I very much am looking forward to the Q&A where you can all tell me how wrong I am. So the background, and as a reminder, this is sort of bringing us up to speed with where we are in quantitative social sciences. So economists, sociologists, geographers, basically all of us are interested in trying to understand society, which is why it's nice to be at SRI, because you're also interested in society, and human behavior. Quantitative social scientists do that using data. And so there's two sort of streams, qualitative and quantitative. And my talk is going to be focused on quantitative social sciences. That's not to diminish or belittle the contributions of qualitative social sciences, which are very real and very impactful and very important. It just happens to be where my expertise is. So before we can do quantitative social scientists, we need to move from an interaction that happens in society into a data set, basically. And in terms of historical records, the very earliest records that we have of that happening are censuses. And the very first ones of those come from China, but also the Middle East, and those go back thousands of years. So there's this attempt in doing that to move from some phenomena that happens in the world, happens in society, to an entry in a data set, in a spreadsheet, basically. And of course, when we're doing that, that's necessarily a simplification. So we're losing a lot in that process. It requires judgment calls, it requires measurement. And all of this means that that process of going from something that happens in society to an entry in a data sheet, in a data set, all of that reflects the power structures of society. So just to take an example from Australia, so Australia comes together in 1901, and at that time, it is written into the Constitution that in reckoning the numbers of people of the Commonwealth, Aboriginal natives shall not be counted. Now that clause was, there's a few caveats to this, like that clause was repealed in 1967, and the Australian economic historian in me would sort of like to acknowledge that like it wasn't as cut and dried as that clause in the Constitution may make it seem. But nonetheless, that clause did exist for a large number of years, and the people who were writing the Constitution, they felt that they were able to put that in place. So data always reflects sort of power structures and society as it is. So we started a few thousand years ago. We now move sort of 500 years ago, and these sort of stories used to be very foreign to us until, of course, about 5 years ago when we all lived through a more recent pandemic. But the London Plague of the 1500s, that sees an emphasis from Joe Bloggs died today to one person died today. So we go from a person dying to there was a death occurred. And it turned out, so these were initially created for the king, these sorts of records of plague deaths. But it turns out that there was $1 to be made in this. And so over the course of the 1500s, over that 100-year period, they're selling these, they're weekly occurrences. People go out and they try and work out who was killed from plague in each of the parishes. These are arranged by church parishes. We end up with something like the image. And so you can sort of see that we have sort of the way that the cause of death, the number. So in this case, 21 people were executed in this year, which was 1665. And it's taken about 100 years for us to get to this sort of clean, very legible record of death. John Grant, the founder of demography, one of the quantitative social sciences, famously uses these data to sort of analyze the plague. And interestingly, he very quickly comes up with a notion of what we today, and I'll get to this, I'll return to this later in the talk, in modern times, what we today would describe as excess mortality, which is the year before the plague, how many people died? Okay, 10. The year of the plague, how many people died? Okay, 15. Excess mortality is 15. So we sort of attribute those 5. Excess mortality is 5. We therefore attribute those 5 deaths to the plague. So he's very early on. This is sort of 500 years ago. Okay, so we've got our data. So we put that to one side. So if we want to get quantitative social sciences, we need data, but we also need methods. So we fast forward 200 years, 1700s. Linear regression, least squares, which is a way to fit linear models, is being developed for astronomers. So it's hard sciences, right? They're peering up, they're looking at the position of Jupiter, they're looking at the position of the moon, and they are taking observations over a number of nights. Now, if you're an astronomer, you hopefully accept that if there are differences between your measurement of where Jupiter is today compared with tomorrow, then that difference is due to you. Like Jupiter's not doing anything weird. Jupiter is where Jupiter is meant to be, right? Those differences are on you. And so astronomers were very, very early to think of this idea that those errors in those measurements, they should all cancel out. And on average, Jupiter will be exactly, if we cancel them all out, those measurement errors should all cancel out. And on average, Jupiter should be exactly where we expect it to be on average. Social scientists took more than 200 years to catch up to that and become comfortable with that idea. And one of the reasons that scholars such as Stigler put for this is because Jupiter is always where Jupiter is meant to be, but the number of deaths attributed to a plague, to a pandemic, that's more problematic, because was there a change from 10 deaths this year pre-pandemic to 15 deaths the year of the pandemic? Was that change due to the pandemic, or did we just get unlucky that year? Did we just happen to miss a couple of homes in the year before the pandemic, and so we missed a few deaths? So social scientists, we don't have that ground truth that astronomers did. Nonetheless, over the ensuing sort of 200 years, we do see attempts, but it is really only in the 1800s and late 1800s and early 1900s that we see Francis Galton and especially Ronald Fisher who are, and I will point out, noted eugenicists. So they're developing this machinery to sort of prove their eugenic sort of ideas. But they put in place both the methods and the way of using methods around ANOVA, null hypothesis, significant testing, p-values, correlation, all of these things, which if you've taken an introductory methods course will be very sort of familiar to you, those words that we still use and teach today. So the issue is that all of this was established, sort of hundreds of years ago in astronomy. So it has taken a few hundred years to make its way over to social sciences, but when it does, it happens really quickly. So in 1950, and this is just focusing on economics, in 1950, the percentage of economics articles that used quantitative methods was 1/4, 1 in 4. And in just 25 years, it goes from 1 in 4 to almost all of them, to 84% is using quantitative methods like linear regression and those sorts of things. The percentage that used prose only, so describing economic phenomena of the type that we might think of like John Maynard Keynes or The Wealth of Nations, Adam Smith, that goes from half of them to basically nothing, to 13% over that same time frame. So when it finally happens, it does happen very quickly, or relatively quickly, 25 years or so. But it has taken a long time for us to get there. So fast forward now to the early 2010s, and there's this thing called the credibility revolution. So in the ensuing sort of 50 years, so 1950s through to 2010s, we've been using these things, but the issue is that it's not clear what are we actually understanding. Are we looking at correlations or are we looking at causations? And the credibility revolution of the early 2010s focuses our mind on that difference between causation and correlation. And it turned out that this started arguably in economics, but all of the other quantitative social sciences, so anthropology, political science, sociology, the same criticisms were very quickly adopted by those on the frontier of quantitative methods in those different fields. And so today, if I'm to write a paper in quantitative economics, and I'm on the frontier of quantitative economics, that same paper, except for the literature review, could basically be published in political science, could basically be published in sociology, quantitative political science, quantitative sociology. There is very little difference between the work being done in these different disciplines, and there is essentially no difference in terms of the training at the high end, in terms of the people who are the best at the quantitative methods in political science, in economics, in sociology, all the rest of demography, all the rest of them. And we see this today in terms of joint appointments being extremely common. So for instance, joint appointments between a social science firm, political science, and statistics are extremely common. And we see this at all the top universities, Berkeley, Stanford, and Toronto, of course, as well. Some quantitative social scientists now even call themselves just applied statisticians because they feel that their work just goes above disciplinary norms. It's just across all of them. Okay, so the issues that we currently face. So this is as of today. So we finally caught up with 1,000 years of history. So the issues that we currently face right now are twofold broadly. Firstly, I said that at the frontier, quantitative methods and quantitative approaches, we all agree on what we should be doing. But there's a large body of scholars who are not at the frontier. And so use of methods, improvements. So there needs to be broader improvements in that, and then also reproducibility. So just to give you some ideas, so Vincent Arel Bundock, who's in Montreal, so he and co-authors go through 2,000 articles, and they find that basically almost all of them don't have sufficient statistical power, so statistical power rather than social power, statistical power to be able to actually evaluate the hypothesis that they're interested in. Abel Broder, who's at Ottawa and co-authors, he goes through a similarly large number of articles, and he finds evidence of p-hacking in a large number of them. John Mellon, who's now at Navy College, so this is the third one, He goes through a few hundred studies, and he basically finds that we're using instrumental variables poorly. Drew Stones, who's now at Yale, and co-authors, he goes through regression discontinuity. And these are terms that if you did a second year, undergraduate methods course in social sciences, these are terms that you would be familiar with. So Drew goes through research discontinuity and regression discontinuity, and he finds that again we find evidence of manipulation at the edge. And finally, Anna Trisovic and co-authors goes through replication packages and finds that 3 out of 4 of them don't replicate if you just click run. And even after she and her colleagues do some work to sort of fix some common issues, even then half of them don't run. So that's kind of where we are. So there's a lot of work in terms of use of methods improvements, and those are for people who are like far better trained in statistics than I am. What the rest of my talk is going to be is on the second of what I see as a challenge in quantitative research, quantitative social sciences, which is on the reproducibility side of things. So about 10 years ago, there was a big push on reproducibility, and there was a number of reasons for this. One of them was we had the global financial crisis in 2007. In response to that, economists said austerity measures. And that was largely based on evidence from Reinhardt and Rogoff, all of which is fine. It's just that it turns out that Reinhardt and Rogoff's conclusion that austerity measures are justifiable or good even were based on an Excel error. And if you correct that Excel error, which Herndon and his supervisors did, you find the support for that conclusion sort of completely goes away. So there are a variety of reasons for the focus on reproducibility, but that's sort of one of them. Over the past sort of 10 years or so, there's been a large push around 2 sort of aspects. So this has been replication packages, which is basically just I provide you the code and data that underpins my paper, and pre-registration of analysis. And I'll get into both of these in a moment. But basically what this is trying to do is the image on the big image is Fermat's sort of last theorem. And as all of you would probably be familiar with this, like the funny thing about this is that it's a theorem because Fermat in the margin scribbles, oh, I have a beautiful proof of this theorem, but this margin is too small to contain it. And you can see like the margins are pretty small. So like that makes sense. The issue for Fermat being that it would be 300 years until someone was actually able to prove it. That required very modern technology. And so the chances are that he actually had a proof that was too small to fit in the page, like fairly slim. And it's probable that that he was just wrong. There was no evidence for that claim, and that's basically what those of us pushing reproducibility in the quantitative social sciences are trying to move away from. In terms of where we are with economics, so we're trying to move things from being credible. So we went through the credibility revolution, 15 years ago, early 2010s. We're trying to move from being credible to now being scientific, which means that what I claim to be true, what I claim that I have done, one other person at least can actually do, right? Because if you run around saying that you've got this big claim, that doesn't make you knowledgeable, that just makes you crazy, right? It's only when you can convince others and others can also make that same claim that it becomes knowledge and it becomes science. So that's the push, from credible to scientific. So in terms of first case study, and we'll go through 4, in terms of a first case study, focusing on code and data availability. So this is just, I publish a paper, underpinning that paper for at least sort of the past 60 years has been code and data. So do I have to make that code and data available? The answer until 2004 basically was no. Ben Bernanke, who went on to chair the Federal Reserve, put in place a large number of reforms in 2004 at one journal, the American Economic Review. And he said, look, if you publish a paper with us, you should make your code and data available. This was a seismic change at the time. And I don't want to belittle like the achievement or what it took to make that change, because it would have been enormous. But it turns out that just saying, please provide us with your code and data wasn't enough, because if you try and you go back and you try and run the code and the data that he put in place, that authors put in place following this change in policy, it basically never like works. That said, it's not to belittle the contribution. It's a huge contribution. It's just like it wasn't enough. It was a first step. So 2018, again, 14 years later, 2018, the American Economic Association, which is the publisher of the American Economic Review, they put in place a data editor. And the data editor, Lars Vilhuber, he says, you submit your paper, it goes out for journal, it goes out for peer review, the peer review process does its thing. At some point, the editor says, I conditionally accept this paper. At that point, it goes to Lars and Lars's team. And Lars's team, they say, give me your paper, give me your code and data, and we need to be able to click run, and your code and data need to be able to work to get the results that are in your paper. So those of you who are in like the hard sciences are like, okay, that's like the minimum actual like for science, but this is where we are. This is 2018, okay? And that changes a paper from conditionally accept. It is conditionally accept until Lars signs off on it. And it's only accepted once Lars says, okay, it is fine. And this is a really big deal because typically in quantitative social sciences, we are publishing one paper every 2 years would be like amazing. One paper a year would be incredible. This isn't like a computer science setting where 5 to 10 papers, or I don't know how many papers you end up publishing, but it's one paper every couple of years, and so the idea of a paper being held at conditionally accept is huge. Like that is an awful lot of pressure on a scholar. So since then they've gone through this replication process for more than 1,000 articles, and the way that they do it is they hire undergraduates at Cornell to go through the papers. There's a number of challenges that we face, and we're not unique in this, but in terms of like non-public data, so there's a big push around using cool data sets like Airbnb and Uber and other cool financial data sets. And so those are obviously non-public, they can't be shared. So that's one challenge. And the second is extensive computational requirements. So sometimes the code needs to run on a supercomputer in order to like work. And obviously, it's a lot easier to get funding to run code on a supercomputer once than it is to get funding to run on a supercomputer or time to run on a supercomputer twice because I want to check my results. So those are like some of the challenges that they face. I would point out that this replication process that he has put in place doesn't check whether a claim is correct. So if I can get through peer review the fact that I think that gravity doesn't exist, then Lars will just check that my code and data agree with my paper that says gravity doesn't exist. He's not testing anything, the veracity, the correctness of a claim. It's just like, does the code and data do what's in the paper? The other change, so that's code and data. The other change is pre-registration, and this is an attempt to try and improve the way that we're using methods. So the basic idea with this is that before we do some analysis, we want to try and say, this is the analysis I'm going to do. This is the hypotheses that I'm going to test. This is how I'm going to do it to a certain extent. And so these are pre-registration plans, pre-analysis plans. And we can see some data from Dan Rubinson here. And Dan's at TMU. We can see some data from Dan Rubinson that shows that sort of the number of pre-analysis plans has gone from very, very little in 2013 through to fairly sizable just a couple of years ago, so the pandemic year. One outstanding issue with pre-analysis plans is that there's no agreed upon idea as to what a pre-analysis plan should do. So with code and data, it's we all kind of agree, we should be able to click run, basically, and it runs. Pre-analysis plans range from everything to saying, I'm going to test whether gravity exists, and that's it, that's my pre-analysis plan, to here's all the code and data that I'm going to do once I collect here's all the code that I'm going to use to analyze my data once I collect my data. So it runs the gamut, and there's no sort of agreed upon process for a pre-analysis plan looks like. So where do we stand now? As I said, like this has been a push on this for the past sort of 10, 15 years. So in 2014, only around about 12% of political science articles had code and data available. And as of a couple of years ago, this had changed to 1 in 3. So like that's good. That's faster than we adopted linear regression, which took a few hundred years. But it's still going to be outside my lifetime before we get to a place where we're comfortable with the results. There's also evidence, so from the replication games, which is where we get a whole bunch of people in one room, and it's like a hackathon, but for social sciences. And so we try and redo some paper. And there's evidence, which will soon be publicly released, that if we just look at the papers from 2022 onwards, so the past couple of years, that these can be replicated. So like there is positive signs, but the history of social sciences is that it takes us a long time to sort of get there. Okay, so what are the sort of the changes that I think that we need to make in order to move us forward, and how do these changes allow AI, particularly LLMs, to help move us forward quicker than we might otherwise be? So moving to part 2, which is workflows, and especially just being very open about our workflows. So a workflow is sort of a way of identifying the tasks that we do. So focusing on a Bayesian workflow, this first one up the top. So Andrew Gelman puts in place, well, a Bayesian workflow looks something like we build a model, we do some inference, and then we check the model. And that's great. That's a good workflow once we have data. A slightly more expanded workflow, so this is the second one, a slightly more expanded workflow might add in some aspects around data collection, some aspects about measurement. Remember I said that we're very concerned about measurement in social sciences. Then we might do our cool methodological workflow, and then we might try to do something with our results, like we might try and make a decision based on that. And so that might be an expanded Bayesian workflow. The issue here is that this still requires like a lot of work. So you either need armies of undergraduate RAs, which requires like an army of funding, which in quantitative social sciences we often don't have. Our funding is typically lower than in hard sciences and computer sciences and things like that. And also, and we'll see this in a moment, but like the data are massive. Our code are massive. Like even with the most talented, most energetic undergraduate RAs in the world, you just can't pick. You can't win them all. You can't get all the issues. And so, what we want to do, and what my sort of workflows work pushes us towards, is that we wanted to use computers and just to like telegraph the part 3 of the paper and AI to be able to do some of this for us. And in particular, we want to draw from software engineering testing. Okay, and the software engineers are going to be like, your innovation is testing? And it's like, yeah, our innovation is testing. And we want to draw from statistics, simulation. And again, the statisticians are going to be like, your innovation is simulation. But those are the 2 aspects that are kind of missing from our workflow in terms of based on what I see. So we simulate our data. We can then add tests. That then allows us to add tests at every aspect of this workflow. Automated testing, which then allows us to move towards more scientific conclusions. Okay, so simulation, just in case you're not a statistician, like me, you're not a statistician. So simulation is widely used in statistics, but it's less widely used in quantitative social sciences. It is, in statistics, often the first step of any project. So we will simulate some data, we will then run the model, and then we will then look at what comes out of our model given that simulated data. Why do we do that? We do that because our models are like really, really complicated. And we want to know that if we've got some weird thing coming out of our model, that it's because of some weird thing happening in the model, not because of some weird thing that happened in the data. Because we know exactly what was in the data because we simulated it. So that's why we want to simulate. It also forces us into the details, and it makes us really think about expectations for our data. Finally, it allows us to think about what we, it allows us, we can share simulated data, even when we can't share the actual data. So patient, if we think about doing some work with a hospital, right, we can share simulated patient data because that's fake, even though we can't share actual patient data. In the case of a workflow, we also need simulation to give us something to test. And this is like not a new idea. This is very old. So if we go to sort of adaptive control design, so one of the innovations of the Apollo program was the astronauts, they weren't actually flying the plane. They were flying an idealized model that the computer, which was running in the plane, then changed into what was actually needed to keep the plane flying. And so when they moved the joystick or whatever it is that you move when you're an astronaut, they were moving, that was an input into a model that the computer then adapted to make changes in real life. So that the plane in real life would react like the idealized version of the plane. And this obviously takes a while to get running, and the innovations in this are basically come at the cost of deaths because a number of astronauts died as they were getting this process up and running. But this isn't a new idea. This is a very old idea. So moving to case study 3, the case of the missing sodium. So St. Mike's, which is a hospital down the road, for those of you who aren't from Toronto, St. Mike's has a really cool data science and advanced analytics group. And what they wanted to do was they wanted to be able to take the bloods, the blood work that happens, and then overnight process that blood work, analyze that blood work, and then in the morning when the doctors come in, they can have some sort of warning, oh, you know, you should really go and check on patient X because there's something weird going on with their bloods. Okay, so automated system that's going to automatically look at the bloods and is going to be used to decide which patients we should go and look at in the morning. Okay, so they trained this model on historical data. It worked great. They did really nice testing. And then they started doing silent implementations. So they actually put it into production, but just that last step, telling the doctors, they didn't actually do that. So they did a silent implementation. So they're following best practice, and it's likely they did because they tested the data and they noticed that all of the sodium labs, and you can see this in the image, everything before 15 December, there's no sodium there. They noticed that all the sodium labs were missing. So what do you think happened? And this might require you to think back to your first year chemistry. What's funny about sodium? What is sodium's chemical symbol? So chemical symbol of sodium is Na. And if you put NAs into a data analysis, often what will happen is that your system, in particular, in this particular situation, they were using R will silently drop them. And so all of their NAs were being dropped. And they realized this issue very quickly because if you're missing sodium from your blood, you would know about it very quickly. So they addressed it. But this is a good situation where sort of data testing really comes to the fore. And so now they have sort of a process of data testing in this process. So what does this look like in practice? So just to provide a very simple example, let's say that I'm an analyst and I'm being hired by the Toronto Marathon Association to try and, they want to know how long they need to book the police for. They're running a marathon, they need to know how long do the police need to block off the roads for. So we might be wanting to try and forecast how long it's going to take people to run a marathon, given their 5 kilometer time. So this looks like for simulation, this looks like we'll specify some number of observations. We specify the relationship between 5 kilometers and a marathon, which is roughly 8 times. We say that 15 minutes is pretty fast for a 5 kilometer time. We say that 30 minutes is like okay for a 5 kilometer time, and then we simulate some data. And we can end up with a graph that looks something like this. Okay, so far so good. And so the advantage of this approach is that we know we could set up some tests. So if we had a 5 kilometer time that was faster than 15, say 1.6, then chances are that's wrong. Chances are the person has missed the decimal place and it's actually meant to be 16, right? And a test is going to flag that. So turning now to code, so we want to test the data, and we also want to test the code. So our code are typically tens or hundreds of thousands of lines long, and scattered across multiple files. And the fun thing about quantitative social scientists is that none of us are taught to code, even though code is at the bedrock of everything that we do. So the quality of our code, or maybe I shouldn't impugn my colleagues, but the quality of my code is extremely, extremely poor compared with what you're writing in a computer science department or software engineering field. So we need computers to be able to run a whole bunch of checks on our code. Our code basically never has any tests. And computers can run. We know from software engineering that computers are very good at running a whole bunch of tests if we have the right infrastructure set up. Now, there's a few, I'm drawing from software engineering here, but there are a few differences. So with software engineering, you typically have you've got an Amazon, right? You've got like millions of people clicking around on your website, and they're doing that sort of thing over and over. And so you want your code to be doing that. Typically in quantitative social sciences, we might run our regressions like once, run our paper, and maybe we have to run it once more to get it through Lars or Lars's team, right? So it's a different setup. There's different priorities, but the fundamentals we can draw from software engineering. So what does this look like in practice? So we can write some tests that test our observations, and critically, based on the simulated data, we can run some linear models and we can get some estimates around our coefficients. And so we can test our coefficients, and then we can run our linear model, and either side of that, we just run some tests either side. So it's not a big deal. It's not a big change to what we're already comfortable with doing. It's just a few lines of code. Okay, so the fourth and final case study as to why this might be important comes from excess death, and rather than excess death in the 1500s, it's excess death from the most recent COVID pandemic. And so Knudsen et al., they build a really cool, really impressive model of excess death for every single country due to the pandemic. And so we look at the number of deaths that happened before the pandemic, we compare them to the number of deaths that happened in a year of the pandemic, and based on that, we can kind of have an estimate of how many people were killed by the pandemic. We use a Bayesian model because we don't always have data for every single country. So in Canada, we've got good data, that's all good, but not every country has good data, and so that's why we need a Bayesian model so we can borrow strength from countries that do. Okay, I'm using this as an example, but it's an example because they did the right thing. Right, so this isn't an attempt to pick on them or anything. This is an attempt to call them out for doing the right thing. So they publicized their estimate, and the estimate of their initial German excess death was 195K. And the fun thing about, so these were demographers. The fun thing about demography is that there's a center for demographic analysis in Germany, and so it just so happens that there's a whole bunch of experts on demography in Germany who said, look, that number is wrong. There's no way that number is right. And the reason that this wasn't picked, and so they re-examined it, they looked at the data again, and then they updated their model, and they get revised estimates down to 122K. So it's quite a difference, right? Almost, 70K difference in estimates. So the reason that this wasn't identified is that the way that you identify issues in these models is you flick through all of the countries' estimates, and you flick through them country by country, and you look for weird stuff. And it's just impossible to be an expert in what is weird for every particular country, right? You just can't do that. Any one person can't do that. And so they missed it, they were called out on it, they updated their model, so all good. The paper was published in Nature, so it's a happy ending for everybody. They did the right thing. But the reason that this was identified was only because we had all of those experts in demography in Germany. So how many countries do you think that their model is wildly off for, so possibly as much as 70K deaths, where we just didn't happen to have a whole center dedicated to demography in that country? And the answer is probably also correlated with various power structures. If you don't have a lot of, GDP like Germany does, chances are you can't afford to fund centers of research excellence and things like that, like Germany can. And so there's probably a correlation in terms of our errors with various power structures, which is why we might care quite excessively. So the other advantage of these tests, and this was what my book, which you mentioned, thank you very kindly, is all about, is implementing these tests. And the nice thing about this is, even if we're using hospital data, we can still share those tests. Like, there's nothing confidential about those tests. They can prevent known errors, and they can help our models satisfy expectations. And all it is doing is codifying what we already just do in our head. It's just like writing it down so that we can actually convince somebody else that we've checked for this. So we can convince a German demographer that we've checked the German estimate of the German coefficient. Okay, so in terms of like the open questions in terms of testing, there's a huge bunch. For part 3, I'm just going to focus on the last one, and the answer, in my opinion, is large language models. So how can we automate the creation of model and data tests? To give it away, the answer, I think, is large language models. The reason that this is important, the reason that we need to speed this up, is because we've seen how slow social scientists are in adapting this. And it turns out that it's not just social scientists. Max Planck has this sort of famous quote about how science just advances one funeral at a time, but we don't have time to wait for that, right? We need to advance a little bit quicker than that. And I think that AI can help us. So I'm going to talk about 3 particular problems that I think we can use AI to help us in terms of adopting these better processes and challenges that they can solve. The first one is monolingualism. The second one is path dependency. So basically, like, once you've already been doing something a particular way, once you get used to just writing some code and clicking run and submitting it to a paper, to a journal, like, that's the way you kind of tend to want to keep working, right? And that's okay, that's completely normal. And the third one is lack of incentive to change, because basically all of the structures are set up so that so long as you publish your one paper every couple of years, like, that's fine, you'll get tenure. No one's really going to care too much if it turns out that you arguably caused like a bad reaction to the financial crisis. Like Reinhardt and Rogoff, they're fine. There's no incentives to change, right? So these are the 3 areas that I think we can use AI to try and help us. Okay, so monolinguals. So quantitative social scientists, and this will seem weird to the CS crowd, but quantitative social scientists typically only know one language. So in economics, it's often Stata. In others, it's just Excel. In some, it's SPSS. And this is a friend like Ash. So like Ash is totally okay with it. I'm not picking on Ash, but this is just like this example of tweet. So Trump says, he says mean things about other languages, and he's talking about natural languages, obviously, but he's saying, there's these people, they come into our country, they speak these foreign languages, nobody speaks them. And Ash retweets and he says, like, this is how I feel about Python. And this is just like a fun, like, this is clearly tongue in cheek. He's clearly just having fun with it, but it is kind of indicative of the quantitative social sciences. We typically only know one language. Now, this isn't to pick on any one language, like Stata, Excel, SAS, they're all fine. The issue is that if you only know one language, like, you just got a hammer, you're just going for the hair, you're always using that one tool, when actually there's different languages that are good for different things, and we might like to do that. We might like to try and take advantage of that. And so the question that a current research paper with some undergraduates, Sarah and Allison, and an incoming PhD student, Inessa, is looking at is trying to answer the question, can we use LLMs to translate code from one language, typically Stata or R, because that's the resources that we have in the replication packages. Can we use LLMs to translate Stata or R into Python? And the answer, just to give it away, is like typically yes. We can use like super talented undergraduates to really quickly translate these replication packages. Again, these are like tens of thousands of lines of code in like just a few hours. When they do that translation, they often find, and I'll show some examples of this, they often find issues. And so that's the advantage of translation. Those of us, like, one thing that's nice about Canada is that I don't have to sell you on the benefits of multilingualism. But those of us who speak another language, that when you go between the languages, you do sort of find things that are odd about your thinking in one of them. And the same thing is true in code in programming languages. Right now, the LLMs, based on our research, they seem to struggle with language-specific packages. Inconsistencies between different files. I think this is just a context problem, but right now, if I change something in one file, it's not necessarily being brought across to my changes in another file. And a huge one, and I think that this is I think that that's a solvable problem in the next couple of years, but a bigger one is that they don't check that what I am claiming to do in the paper is actually what the code does. Okay, so to give some specific examples, so can we do this? So here's some Stata results. And again, this is not to pick on the author of this paper, whom I'm not naming, because this author has done the right thing. They've made their code and data available, so this is admirable that they've done this. So we can run their Stata code, and we get an estimate, for instance, this first estimate of 0.0105. And my talented or our talented undergraduates can use LLMs to translate this into Python in a couple of hours, and they can get that exact same estimate. So you can do this. It's pretty remarkable that you can do this so quickly and so cheaply. And these all match. So that's the good. Some of the issues that they pick up, so they pick up typos. So there's a situation where the code in the replication file just cannot be run because of typos. So this is just a .tta, like that's a small, that's just a typo, that's okay. They identify syntax issues, and LLMs are great at identifying syntax issues in our experience with this project. So in this case, we're missing a command to actually run the regression. And again, this is not to pick on this author. They've done the right thing. This could happen to any of us. In terms of where it did not do so well, so bin scatter is a language-specific package. And basically, if you think of a scatter plot, basically it tries to group them into bins. So it's trying to get the best of both worlds between a histogram and a scatter plot. That's basically what it's doing. There's no equivalent package in Python. And so we really fell down on this. So the first set, these first two tables, these first two graphs, they're from the original paper. The middle graphs, they are, if we click run on the Stata replication package, so we get what is in the paper. So that's great. That's better. And then our last set of graphs, and if you look closely, you'll notice differences. Our last set of graphs are those that we construct with Python. And so it's just not quite getting there. So it's still struggling with having code-specific libraries, and that makes sense, right? Because in order to make this work, you'd have to rewrite the whole library, but there's a lot of background knowledge there. That's not happening. Okay, the second thing, so path dependency. So once I'm doing something, I don't want to have to update. So you tell me, well, I don't want to have to worry about these data tests, Rohan. That's a hassle. I don't know how to do them. I'm not interested. So the question is, can LLMs write data tests so that you don't have to? And the answer is yes. So with a industry partner, the Investigative Journalism Foundation, so they're a nonprofit news media organization. And the way that they do the way that they come up with their news stories is they've built these massive data sets. And the one that is of interest for this talk is they've built a massive data set of political donations. So long as you meet some various thresholds, if you make a donation to a political party in Canada, it should be reported by a province or the federal government. The issue is that each of those provinces and different levels of government are going to report it in different ways. And so there's a huge data cleaning exercise in terms of scraping those websites and bringing it all into one data set, one database. And so the IJF paid an experienced data scientist for 6 months to come up with a suite of data validation tests, exactly like St. Mike's did. And she was able to put this in place, and it's a high quality product now. And so every night our scrapers, the IJF scrapers run, and before we put our data into our data set, that's public, we check it goes through these tests. Okay. So the question is, can we use LLMs to generate a suite of data validation tests that are equivalent, somewhat decent, compared with those that were generated by a very experienced data scientist? So to add some more detail to this one compared with the last one, I know it's a technical audience. So in this particular situation, we test a few different settings. So we consider 4 different temperature settings, 2 different roles, 4 modes, so GPT 3.5 and GPT 4, and a few different prompt engineering attempts. So just looking at this first graph, so we're evaluating the decency. So how good were these tests? And that decency is evaluated by human coders, as well as large language models, but they typically agree. And so based on our prompts, as we add more detail to our prompts, in general, our decency is improving, and especially when we have very little detail in our prompts, we get very low decency ratings. And so there is something to be said for improving the quality of the prompts. And this all tracks with other literature who have done this in other contexts. Temperature. Temperature, it kind of controls how like random LLM is. So with temperature of 0, it's not deterministic, but it's like pretty close to deterministic. Like temperature 0, if you run the same prompt, everything, like you should almost always get the same output or like very, very similar. And so again, with lower temperatures, we do find sort of lower rates of decency. And surprisingly, with higher temperatures, which I was expecting it would go off the rails with, it didn't tend to go off the rails too much, although just a little bit. So there is some sweet spot in the middle where we think that we've got some like improvements, a sweet spot of temperature. And finally, in terms of few shots, in terms of the number of shots that we provide, and so for those of you who aren't familiar, so shots is basically the number of examples. So if I provide no examples and I just say, what is the day? Then that's 0 shot. If I say yesterday was Tuesday, what is the day? Then that's 1 shot, and few shot is providing a few different examples. So shots is number of examples, basically. And so what we would expect is that as we provide more examples of what we want, that our decency improves. And that's largely what we see. We see that with 0 shot, we get very poor decency. So there is some benefit to sort of having some expert there who can tell it this is what we're expecting. So it's not a case that right now, in terms of our experiments, we wouldn't conclude that you should just let these things loose to run data tests. We should say that you should let these things loose to write a first draft for your expert data scientist. Finally, dealing with the third thing, lack of incentive to change. So the question is, can LLMs improve quantitative social sciences code so that you don't have to? So this is like basically, do I have to bother like learning how to code better? Or can I just ask LLMs to improve the quality of the code? And the answer is like, I think yes. So basically with a unique combination of AI expertise, so Chris Madison, who is a SRI affiliate, business expertise, who's Zane Schwartz, and data science expertise, Annie Collins and Michael Chong, we're putting together Human Research, which is running through the Investigative Journalism Foundation right now. And what we are trying to do is we're trying to take code and ask the LLMs to improve it. So just, I wasn't brave enough to live code it, but I'll just share a YouTube video. So to say that I'm a data scientist and I've written the following code. Those of you who know R will notice that there's a small mistake here in the summarize function, but right now we've got it working for R, Python, and Python. So I submit that repo. And that creates a post on our slide. Assuming this looks legitimate, I can copy it and I can submit it. That creates an issue in our core repo, which causes GitHub Actions to run. This will take a few minutes to run, so I'll come back to this in a few minutes. The way that scripts work is that it automatically forks and clones the initial repo. It sends the script to the LLMs alongside with a bunch of prompts, and then automatically picks which of the best responses should be submitted back. It makes a commit to our clone of that best response. That's all done automatically.
So then the human analyst can go to the clone, decide whether they want to make it, submit it back to the customer, and if so, share it with us. So in this case, we're done, so we can go to our record. So we can see that we're one comma ahead. And in this case, the LM did find the issue, and the rest of this looks sort of good. So we'll go first.
So that's basically how it works. So that was like a toy example. One of the things that we learned super early on is that actually the LLMs really prefer real examples, not toy examples. So this is an example of some real real code, and I'll just walk through the changes that it's sort of suggesting here. So before, we've got a whole bunch of comments up the top here. We're importing a library that we're not actually using. We've got some sort of like not very nicely named function argument here in fname. Again, we have some commented out comments, some comments here. And we're reading in a string in a way that is system specific. And so automatically, we ask the LLM to generate a whole bunch of improvements. And then we play off and create an ELA ranking between those different opportunities. And then one rises to the top. And this is the one that rose to the top. So we're importing a library, which we're going to use later. We're improving that file, that name of that argument from fname to file path, so it's more clear what it's done. We've added doc strings, which to help the readability of the function, and we've made the reading in of the data set to happen in a system agnostic way. And so we think that like there's something. So even if you don't want to change the way that you write code, and that's perfectly understandable for a quantitative social scientist, we think that we can use LLMs to really speed up the way that we can improve the quality of the code that's written. So just to conclude, I think that we have a real unique and real exciting opportunity to do something really special with large language models and AI more generally. One of the key challenges that we've had is building like exchanges of knowledge between AI experts and quantitative social scientists, because AI experts right now, they've got a lot of other exciting things that they can be doing, and it can be hard to get them interested in sort of our social science problems. But I think that if we tweak some of the incentives that we have within the quantitative social sciences, so maybe this is in terms of like journal publications or in terms of academic rewards and acknowledgements, then this can sort of allow us to move forward, and hopefully it won't take us 300 years to improve the way that we're doing things. So I'll leave it there and just say thank you very much for having me, and happy to take any questions. Stop screen sharing? Sorry? Stop screen sharing?
Sure, yeah. All right, thank you, Rohan, for that very engaging talk. Although I strongly disagree with the claim that in computer science we write better code, and that does not apply to me. So perhaps I'll be the new customer of your tool. All right, so we are now pleased to move into the question and answer session of this talk. And just as a reminder for our in-person participants, you can raise your hand if you have a question, and please wait until we call upon you to ask your question. Remember that this room is equipped to pick up the sound from all over the space, so there won't be any need for a mic. Once I call upon you, you can just ask your question. But that also means that everybody else, please do not engage in side conversations until we are done with the Q&A session. Otherwise, that will be picked up as well, and it will make it very difficult for the people on Zoom to be able to clearly hear the question and the response. And for people who are joining on Zoom, I'll be monitoring both the chat and your raised hands. So if you have a question, preferably you can raise your hand, and then I can call upon you to unmute and ask your question. And if you are in a space where you cannot unmute and ask your question yourself, then please put it in chat, and then I'll be happy to pass it on to Rohan. All right, so with that, I'll open the floor for questions. Yeah.
When you say like a spell check for data science, it makes me think of something like Copilot, which is sort of more like inline where it's sort of giving you suggestions or maybe identifying things as you go. Do you think the sort of like I guess the workflow of like write your code, submit to an LLM, have it sort of process it all is like, do you think that's more sort of efficacious than sort of just something that's there with you as you're coding or?
Yeah, so this is an age effect, but back in the day, if you wanted to run your spell check, like you had to like go up to the file and click run spell check. And so that's the way spell check used to work. And so that was sort of the model. We see the approach as different to Copilot because Copilot is like actively generating code for you, whereas spell check like doesn't do that, right? It checks whether you've made a typo in the words that you've written. And so I see it as slightly different to Copilot.
Just to follow up on that, do you kind of see an advantage in one method versus the other, kind of doing this, even the spell check, doing it as the code is being written versus afterwards?
The issue is intent. And so I think with doing the spell check as we go, it's hard to look at between different files and our intent as to what we're trying to achieve overall. And so I think that there's room for, at the end, like trying to improve things.
That's wonderful. Yeah. Thank you. Any other questions? Yes.
I have a question. Thanks for an interesting talk, and thanks especially for making it accessible to a non-specialist audience like myself. I found it very interesting and easy to follow along. So I just wanted to ask a little bit about one particular error mitigation method that you gave the example of the Apollo pilots who use the computer picks up their movements and then translates it into mechanisms for flying the plane. So with that type of system, is the idea there that that secondary function like that computer would reduce human error? Like would it pick up on one of the pilots doing something that would accidentally crash the plane and it would prevent that from happening? I just want to clarify that I'm understanding that.
Yeah, so the issue that they were trying to solve was that the planes were like very poorly aerodynamic and they were very hard to fly for a human. There was too much that needed to be changed in order to keep it flying. And so they needed to be able to simplify it so that you could, with just one little input device, be able to keep it flying and make all of the changes that you had to be able to make. And so the computer was doing an aspect of doing that. It was making it possible for one person to be able to fly these things.
I see.
So there was just too much going on in order to fly the plane for one person to be able to do that at the same time. And so I see that as analogous to what we're trying to do with our huge data sets. Like there's just too much interaction, too much code for one person to be able to keep track of all of it. And so this is why I think that we need to act through these simulated data sets and act in that way rather than directly.
Got it. Thank you.
So similar to, yeah. Yes.
So Rohan, are you saying that really fundamentally the computer is flying the plane and the pilot is adding the fine tuning?
So that's what basically happened with the Apollo. Like the computers were flying it and the pilots were in control, but they weren't controlling everything because they couldn't. It was just impossible to be able to do that.
So it's early days form of abstraction?
I really I was so taken when I learned about all of this stuff because I saw it as exactly what we're trying to do in terms of like human at the wheel with AI and all of that. I just saw, oh wow, there's just analogies.
Thank you. You had a question?
Human in the loop.
Sure. So with the LLM workflow, have you noticed any trends on the type of errors from like social science, quantitative social science, that repositories? I'm just wondering if there's any trends in terms of the errors that the LLM is actually picking up and recommending for correction, and maybe what the implications of that might be for education, like for improving humans too at the same time.
So one thing that it always picks up is a lot of typos in terms of what variable is being called. So in that paper, and again, I don't want to dwell on too much because it's kind of like making punishing somebody for doing the right thing. But like in that paper, there's a number of times where the wrong variable is called. And so it notices that immediately because it's inconsistent. And when you try to rewrite it in Python, you need to specify the variable. So that's one thing in terms of just being very careful about which variables you're writing down. So that's one thing that I've certainly in my own practice, I've become much more aware of.
Thanks for a really interesting talk, and lots of very great examples to give. So I just want to see which of these two kind of reads on your kind of thesis you agree with. On the one hand, you might say you're putting the LLM directly into the workflow. Or on the other hand, you might say that the LLM sort of creates the tools that you're ultimately using in the workflow. And the reason I think the difference between those two options matters is LLMs aren't deterministic. Like, if you run an LLM one time, it generates a different output than at a different time. And so you might worry there's actually a tension between using LLMs and trying to advance the aim of reproducibility. I wonder, I don't think that's a problem for your view, but for your kind of your approach. But I just wonder what you thought about that.
Yeah, I think right now the LLMs aren't at a stage where we can just let them loose. So I think it's very much like the second, where we're just trying, the second of what you put forward, we're just trying to use them to try and tidy up after us or make some small improvements rather than allowing them to go through and be worried about the fact that they're not deterministic.
Right. More questions from the room. I just want to remind the Zoom audience that you can also raise your hand or put questions on chat. All right. Yes.
I really appreciate this point you made about getting AI experts interested in quantitative social science and data more generally.
As an AI expert who is in social science.
I've seen this issue with interest in things like the Toronto Library data sets, which have huge data sets and interesting data, but very little other than our Professor Lyons here has actually done research on AI in relationship to those data sets. So I'm very interested in this question that you posed about incentives, or this idea about incentives. Do you have any more detail that you could share with us about ways to incentivize that specific kind of intersection?
I think it's the issue right now is like the AI experts aren't even interested in being at a university, right? They're going out and they're working in industry.
They'll come back.
Right now, the outside options are so attractive.
Yeah.
But I think we have very interesting problems. And so we saw that with the pandemic, right? All of a sudden, biostatistics, which kind of maybe wasn't, or forecasting disease, which maybe wasn't the most exciting of area for AI experts, sort of did become an element of interest to them. So I think that there's possibilities around that, and making our work more relevant to them could be.
So highlighting the sort of interesting problems that exist within this space,
Yeah.
and pointing to the ways in which they might have public impact.
Yeah, and so Ashton, who's in the CS department, he's an AI expert, and he publishes in social sciences problems. And I don't know, like I've never met Ashton, but based on looking at his research, I think that one reason that he's interested in that is because he's able to analyze the Spotify data sets, and he uses those Spotify data sets, those massive data sets of like what we listen to understand preference formation and how that changes over time. And that's a unique, like he could never answer those questions if he was only in a CS department, because I don't know, maybe you do care about preferences, but or society, but maybe not also. So I think that like trying to open up our data sets maybe might be of interest. I think that if we could open up some financial data sets, that might be of interest to folks. Yeah.
Perfect. Let me go to Bart over on the Zoom. Bart, can you unmute and ask your question?
Sure. Can you hear me?
Yep.
Oh, wonderful. So I had a question about data set interoperability. So as you're encouraging people to publish their data and their code, we're going to run into this problem that, this data is not interoperable. So can we've been kind of working on these, and a lot of researchers have been working on integrating these data sets, but can you see LLMs sort of automating that process, or anything else from your work that could contribute to this? Thank you.
So I might be misunderstanding what dataset interoperability means. But in terms of my understanding, like one issue is that, so for instance, with a CSV, if you open it on a Mac, it might look different to if you open it on a PC because of how the program reads it in. So Excel might think that something's a date, whereas the Mac equivalent might not. And so I think that trying to push people towards file formats that are agnostic. So for instance, Parquet might be a way forward. Partly, I think that will come if we encourage like social scientists to realize that the outside options, which like is data science basically, is very interested in this problem and back it out that way. But yeah, it sounds like maybe I've misunderstood what data set interoperability is. But did you want to follow up?
Yes, so let me just quickly clarify. I meant more at the conceptual level. So, you know, if two data sets are talking about, let's say, people, but in different ways conceptually, can you actually, you know, link those two concepts together?
Yeah, I'm not sure about ways that we could do that. I haven't looked at anything in that aspect.
Okay, thank you.
Thank you. More questions? Oh, yes.
Thanks for your talk. It's really good. And as one individual said, you really did a good job of making it understandable to the whole audience, even if it was a complex topic. I really like quantitative analysis and quantitative social sciences. But sometimes I feel that the literature becomes too complex and more emphasis is put on the quantitative aspect rather than concern on the social science impact, or that's lost in translation. So how, and in a way that kind of creates quantitative social sciences to be its kind of own clique in many ways. How do we move forward to make our literature more understandable, more accessible to individuals who want to engage with it, especially in an interdisciplinary way, to make sure that it also isn't misunderstood, and also to a more wider society who might want to interact more with academic literature, but doesn't necessarily have the years of experience as other scholars might have. How can researchers keep that in mind moving forward to ensure that their impact doesn't get diminished by their concern over data and quantitative analysis? And on top of that question, are LLMs the answer to that problem?
So to take the second question first, I don't think that LLMs are the answer to that problem. I think that for me, it's been industry ties that have made me like try to be much more hyper aware of like not disappearing down some social sciences literature rabbit hole and ensuring that what I'm doing is relevant for the stakeholders, in this case, the Investigative Journalism Foundation, or there was the example earlier around mortality estimation. So that was all done for various UN organizations. And so I think that one way that we see this, like avoiding it, is encouraging sort of industry affiliations and integration. So this might be trying to get grants, joint grants with, or my tax grants with an industry group here, if you're in Canada. Yes, for me that's been the way.
More questions? Avery?
Hi, thank you. So as a literature professor, I appreciated T.S. Eliot being in the slides. And I was thinking about between the idea and the reality falls the shadow. I guess here the shadow is the Excel user error. So it sounds like the Reinhardt Rogoff thing was a user error. Is that right?
Yeah, that's what I had in mind. Yeah.
Okay, and then there was another sort of a software language error with sodium being not applicable.
Yeah.
So where are the failure modes that you see as a problem for the use of LLMs? Because you're working with this, where do you see the possible errors coming into the process and the workflow that you've described? Where do you see the kind of, I don't know, failure modes that you're trying to address?
So right now, the LLMs have been in terms of my use, they've been trained on, GitHub and those sorts of things, typically big software engineering repositories, and they are tailored towards that. But the type of code that we write in data science and that we need to write in data science is very different to that. So for instance, we're really interested in like being able to set up a model and evaluate a model. And there's just very little of that in the current training data sets, as far as I'm aware of the training data sets. So what this means is that the LLMs, they consistently try to impose software engineering norms and practices on the code that is perfectly fine. And so it's these like false changes, like these changes that don't need to be made. So for my area, which is going to be like, quantitative social sciences, we don't need to change everything into a function. Like we just don't. We can run perfectly well without doing that. But often an LLM will just want to do that. And so right now the tools need to be fine-tuned.
There was one more question.
Yeah, I'm just wondering, you mentioned that there's a lot of, I can imagine there's a lot of sort of prompt engineering work that goes into getting these things to run well. Is there sort of how do you and the team sort of approach this? Is it something that's like, you have like a rigorous process for doing the prompt engineering? Is it a lot of sort of just sort of iteration, testing, tweaking, kind of seeing what works, what doesn't?
It's been a lot of that, iteration and seeing what works, because ultimately you can only test like a small handful of things, because ultimately it either needs to be evaluated. You can only evaluate these things. Please correct me like if I'm wrong, but in my knowledge is that you can only evaluate LLM outputs in one of three ways. One, you pay human coders, which, so there's a limit to how much you can evaluate each day. Two, you ask LLMs to evaluate LLMs. And so there's obviously technological limits on that. Or three, you just like run the code. And there's obviously technical limits on that. So none of these three ways of evaluating the code is great. And so it does limit the number of experiments we can do in terms of the prompts. So the key has been having super smart, like educated, experienced people. So in the case of these undergraduates, or Annie and Michael, who are experienced data scientists, that has been the key, because they know where we're sort of trending and can try and course correct early on. So for now, yeah, that's the only way. We just can't do that, the thousands or millions of experiments that we would need.
That makes sense. Thank you.
I have a question that I wanted to ask regarding the previous part of your talk. So you talked about kind of this the computational challenges of doing the reproducibility test, right? If something required lots of computational power, how do you kind of reproduce that? And then kind of you talked about the possibility of passing the onus back on the authors. And so how much kind of do you see this as feasible? So if reproducing the data, reproducing the results requires kind of computational power, requires more data collection in some cases, maybe how much do you kind of see this as a feasible thing that you kind of tell the authors that, hey, if you were previously thinking of needing so many kind of gigahertz days worth of computing to run that much amount of kind of computing, now just double that in your mind. So basically say that I can only write a paper that kind of requires simulations that require X amount of computing if I actually have 2X amount of computing available to me. So how much do you think that is feasible?
Yeah, so I don't think that it's culturally feasible right now. And this is one of the challenges with LLMs also, because like almost none of us can redo the OpenAI model, right? Because we just don't have the resources to be able to rerun the thing. And so I think this is a broader problem in terms of reproducibility. There is a huge cultural pushback for exactly that reason. It's like, well, I ran it once, it worked. You can't possibly expect me to run it again. And I think that in general, like that's okay. We can be okay with like letting go. We don't have to be like 100% perfect all the time. And if we can get up to like 80% and we have to let go of the ones that require Microsoft to give you millions of dollars, then like that's okay. In my mind. Yeah, that's not what I'm losing sleep over. If theirs isn't able to be redone, but it's an important problem.
There's a question, a long comment and a question on chat. Vishnan, do you want to maybe unmute and ask briefly ask the question part of your comment? Meanwhile, if there are more questions in the audience.
You could ask the question at the end there. Person's asked, we saw some case studies on journals imposing data or replication policies. Are we seeing any evidence that funding agencies are starting to impose such conditions as well?
Yeah, and so just by way of background, Wisham was a student a few years ago, and the paper, the second case study I think I showed, where we were translating from Stata into Python. He initially identified this paper as being of interest and potentially of having some issues. So he's an expert in some of what I said earlier. With regard to the question, so the question is, we saw some case studies of journals imposing data and replication policies. Are we seeing any evidence that funding agencies are starting to impose any conditions as well? So I don't know of punitive funding agencies saying like, you must do this, otherwise we'll take away your funding. What I am seeing is new funding agencies giving you money to do this. So for instance, the Open Philanthropy, which is a big funding agency, just gave, like, I was a minor part of the team, but just gave me and a bunch of others like $250,000, which is huge in computer sciences. I realize it's nothing but CS, $250,000 to do massive amounts of replications, partially using LLMs. So and it was a super easy application. It was like 2 pages. And so you compare that with the old funding agencies, and it takes, however many pages to get less money. I think that there's exciting new funding agencies options, which
You have time for maybe one final question?
Very interesting talk, Rohan. Obviously very cool. And I'm really impressed by your tool at the end you created. But that tool necessarily is new code that I've already written, right? Like I've worked on this code for maybe a paper or something, and I want to check for reproducibility, or I want to see if there's an error I can improve my code, which I always say I can every single time. But there's no sort of discussion whether or not the code I've written is appropriate for what I'm trying to test. There's no sort of like any sort of hypothesis testing there or other elements to check for, like, I don't know, limited variable bias, multilinearity, or something else, right? Is there any interest in your work of extending that tool to include some sort of actual thought between the data that I'm analyzing and the questions that I'm asking?
Yeah, so I would love to, I think that we're tracking that way. So I'd love to be able to have the PDF of the paper and the code and like do these two match up. Right now, we have to do that with humans. And in this case, Wisham was actually a human who did that and identified issues. But right now, I don't see the LLMs as being able to do that. And I think we're at least a year or two away from seeing anything on that. But hopefully I'm wrong. But yeah, right now it's not. But I think that that's the whole ball game, right? That would be really cool.
It's amazing how at least a year or two away is now considered kind of a long time.
Yeah.
Yes.
So you realize the Pandora's box you're opening, because if you take it back one step, it's not, is this the right code for this question? It's, is this the right question?
Yeah, it's exciting.
Well, maybe take humans right out of the equation, and then I think we get back to Jeff Gittins' cautions that he and his colleagues currently have.
Well, they would certainly know much better than me about the
I think it's us gray-haired people, we're just more cautious about what world we're gonna leave behind.
All right. So thank you very much, Rohan, for that. For that very wonderful and engaging presentation. And thank you for everyone in the audience, both people who are here at the Rotman School of Management and people online for joining us today. Please also join us next week, March the 13th, Wednesday, as we welcome Marlene Coffey, who is an assistant professor in economics here at the University of Toronto and an SRI faculty affiliate, who will talk about unlocking innovation, the use of natural language processing to uncover scientific bias. And the seminar will return to an online seminar starting next week again. So we look forward to seeing you all then.
And as a reminder, there is still some time here that if you want to hang out and I believe that we have maybe the room booked for a little longer or, okay. And there's more pizza outside left, more soda and everything. So yeah, please feel free to linger on.